So, hello everyone, and this is our last topic basically of hoops, which is called encapsulation, right? So again, now what does it means, right? Like earlier when we were doing something called as logical programming, or we were doing a scripting manner of programming, what happened was that we used to make data as a different, we used to make functions totally different, so there was no much relation between variables and functions. But now when we use class, right, then what happens is that we are now basically able to somehow correlate both of these concepts, right? And moreover, what happens is that why we use oops in a project is because they are tightly coupled now, right? Like here we wrote self dot name, self dot servant, so there is only one single object we used to create, right? Like object dot name, object dot surname, object dot year of birth, so everything becomes tightly coupled now, right? So we are basically binding the data and the functions into a single unit, right? So that is called encapsulation. Just like you have a capsule, right? In the capsule, what happens is that everything is contained in the capsule, right? And it is also because of the encapsulation only that we are able to implement abstraction, right? So what is abstraction? Abstraction simply means that you are hiding the background details, and right, like I gave you the example of a phone case. Now if I say that, like, we use the function type, like if I do s is equal to anything I write, and then I write type of s, right? So simply what you do is you put certain input into the type. You don't know how type is written, neither you bother that what is written in a type. So it is a different manner if you explore that how what is the code of type, but it is just like a black box, right? You put the input, something happens inside, and then you get the output, like here I got. So just like capsule, in the capsule what happens is that basically you input sort of your disease, right? That this is a disease, then there is a particular capsule you intake, and it goes in the body and gives output in form of like you got relief from that particular disease. Now you don't bother about how that capsule works, what is the chemical composition of the medicines which is put inside that. We don't bother about that. That is from where the name came, encapsulation, right? So what has happened in this type, or supposedly if I do id, we just, what we are required to do is that we are supposed to fulfill the signature is, if it's one argument, give one argument. If it's asking for two required positional arguments, give the two arguments. That is what only we are able to do. Now the question is that why do we do encapsulation, right? What is the reason for doing this? One is obviously that we want everything to be tightly coupled, right? Other thing is that composition and dynamic extension. These are the two reasons why we do encapsulation: composition and dynamic extension, right? So we'll talk about both of them, right? So let's get started with the one thing which is called composition, right? So as of now, I say that, okay, suppose that I am building a particular car. Cool. And in a car, right, so you have different things, like the three basic things are tires, engines, and a body. So let me define different classes for this. Class tires, f underscore underscore init underscore underscore self comma. Now what a tire can have, if I talk about, a tire can have a certain branch, right? What is the belted bias, right? So you need not to know about these terms, and the optimal pressure, right? So this is all. Now we can write self dot everything. Self dot branch is equals to branch, and self dot belted bias is equals to belted bias. Similarly, doing that for optimal pressure, right? Is equals to opt underscore pressure, right? So I have just simply defined a simple, a very simple, you can say, class for tires, right? So here I can also override the str method self, and I can simply return self dot, okay, let's just return tires, then let's do a backslash n, and then we can simply write something like, we can go for branch, that is str self dot branch, right? Then we can go for another backslash n, and we can write belted wires plus str self dot belted bias, and similarly let's just do it for optimal pressure plus str self dot optimal pressure, pressure, right? So this is your tires class. So I have not done encapsulation as of now. It's simple tires class. Let me show you how it runs. As of now, I am just giving any sort of arguments, and let's just print OB. It wasn't able to overwrite the def method. Let's just see why. Is there some error over here? Belted by cell dot belted optimal pressure cell dot opt pressure. Wait a minute. Yeah, see, it is able to do it. Cool. So we can, just to make formatting more good, we can write here backslash t, which is basically your tab, right? Backslash t. Yeah, so it looks good. So the way I have given the tire class, right? Let me just copy paste the engine as well, right? So what we're trying to do, I'll just tell you within a minute, but as of now, you just type along with me. Let's just copy paste the engine class, right? So it has two types, which is fuel type and noise level. And in the str, let us also give the output something like this. Right, so we can just write over here engine. And here this is the fuel type, like we can give like petrol, diesel, whatever it is, right? So it's that fuel type. Then we have noise level. This will be noise underscore level, right? So this is my engine class. Let's just try to run it and check if everything is fine. Let's make an object for engine, and as of now I'm just giving simple like petrol, and noise level, let it be 2. Let me print the object. See, yeah, it happened. So this is fuel is petrol, and noise level is 2, right? See, now there is one thing, that if you print the object, then only it will happen. If you simply type object, then nothing is going to happen. Now there is one last thing, which is the body, the last class, right? Okay, so as of now, again I say, we have not come into encapsulation, we have not talked, but I'm just making a like somewhat close to what you do in real life, right? So let's just copy it. and paste it. So this is for body, and in the body you have size. So this will be self dot size. Perfect. Now I won't be checking for body. That is for sure that it will be all perfect. Now I have a car, right? And just wait for some time. I'll copy and paste it. So this is a car. In car, basically, what I'll do is, it is just taking some three parameters. Ty is for tires, En is for engine, B of for body. So this is not inheritance. If you think this is inheritance, this is not inheritance. These are simple parameters. Only parameters. Ty denotes tires, En denotes engine, Bo denotes body. So let me remove this function. And this is my def str. So here I am just simply printing the tires. Okay, let me just do backslash n only, right? So this is my whole thing. So as of now, what you're able to see on the screen is that four classes, right? Which have certain parameters. Perfect. What I can have done, what I could have done is that I can have made my car inherit the properties of tire, engine, body. But that doesn't make sense, right? But what if I want to use these parameters, right, of engine, all of them, through car? Okay. So before that, let's just talk about that if I make an object of car, so it simply asks for three parameters. Let me give any three parameters and print C, right? Oh my, okay, sorry, small c. Yeah, so it printed 1, 2, 3. So simply I gave three parameters. I simply gave three parameters. It took the three parameters and printed with the with respect to str method. Simple. But here I said this denotes tire, this denotes engine, this denotes body. Now one very interesting thing which I am going to do as of now is, let me make an object T for tires, right? This is actually very interesting, believe me. Now we have something like branch. Now let's have the branch as parallel. Then belted bias, so it's true or false. Let me give it false. And then at last we have optimal pressure. Let it be 1.8. Cool. So this is an object for tires. I repeat, this is an object for tires. Like if you print it, you can see parallel false 1.8. This happened. Okay, let me just build something, an object for engine. Again, I say we are not doing encapsulation as of now. It's a simple class creation and having, we will talk, like just wait for some time. We will move on to encapsulation. So this is diesel, right? So let the type be diesel and let the noise level be 2, right? You can print E. Yeah, so that is E is printed. Now for the body, let's just say that you have, it says size. Let me give the size as small, and you can print B. Cool. So this is how it is printed. Let me remove all the print statements. Right. Okay. We did it. Now in the car, now is the line where the encapsulation is going to take place, right? So in the car, I'll pass the parameters as the objects of the class tire, engine, and body. I did it. Let's just print C now. See this. There you got whole of the thing. This is your encapsulation concept, right? And yeah, doesn't matter that you write B over here. You can also write anything else. Like I can write KKK. See, it printed KKK because that is what the str method is doing, right? So I can put anything over here. Doesn't matter. Doesn't right? This is my encapsulation, right? It is nothing fancy. But what we did is we performed something very great through encapsulation. Now, through encapsulation, now you will think that encapsulation you were talking about that. Wait, we are just supposed to hide the things, right? So how is it happening? Let me just tell you, talk about that, right? Now it is because what happens is that we are trying to call tires, engine, and body, right? But we are doing it through the class car. It is no inheritance. This is not inheritance. People confuse that this is inheritance. This is not at all inheritance, right? This is nothing but this is a encapsulation. How encapsulation? Okay. Now, supposedly you don't know anything about tires, engine, and body. These classes are not given to you. Suppose, right, you are only given a class car. Perfect. What you are doing is that just like type we did very initially, you don't know what is happening inside type. You don't know. You just put in the input as per the signature and you get the output. Here also, supposedly you didn't know anything. You simply put the input in the object, that is TEV, you put that and you got the output. This is the beauty of encapsulation, and this is basically where we did composition, right? So, okay, let me insert over here and type composition. This is what we did, composition, right? So now we will be, now this is like, I hope this is clear to you that how we basically did encapsulation in terms of composition. Now in the next video, what we will be talking about is that how we can do dynamic extension, right? Like I said, that there are two reasons for encapsulation, composition and dynamic extension. So we'll look on to dynamic extension in the next video, but this is how we did encapsulation through composition. Thank you so much for watching and have a great day.